Welcome to the Math Record. Today I'll be covering inverse derivatives of trigonometric functions. For this video and the next two, I'll be proving the equations for these inverse trigonometric derivatives. The main reason I want to do these proofs is because calculus already has a lot of formulas, and what I want to do is to show you how to get them without actually having to memorize them. So you just need to follow the procedure every time. So all you need to do in this procedure is use the chain rule, some drawing, and some logic. So first, let's start with sine of x. So inverse sine of x. To find the derivative of this, we're going to do the same procedure what we did in our previous video, which is sine, inverse sine of x is equal to x. So just the original function and then the inverse of it inside and give us our same variable. So taking the derivative of both sides, the derivative of sine is cosine. Keep the same function inside. Since it's a function side, we need to use the chain rule. So derivative of our inverse sine. And then derivative of our right side, derivative of x is 1. So that gives us that inverse sine of x is equal to, because that's what we want, is equal to 1 divided by cosine of the inverse sine of x. Well, that isn't really helpful. That seems even more complicated than what we had before. And this is where the drawing comes in. So trig always deals with triangles. Let's say this angle is theta. So the inverse sine of x, well, what does this x value actually represent? If you kind of think about it, let's say we have sine of theta, but this is actually the y value of our original function. So sine of theta is equal to x. That means if we take the inverse of x, we get theta. So when we get this, we actually get our value for theta, but that means what does this x value represent? What's right here? Well, sine is actually just opposite over hypotenuse. So that means the opposite is x and our hypotenuse is 1, because x divided by 1 is x. You could use any numbers too. You could say this is like 2x and make this 2, but the simplest we're going to use is just x and 1, because it's easier to work with. So using the Pythagorean theorem, you can find out what this value is. Let's call this y. So y squared plus x squared is equal to 1. So that means y squared is equal to 1 minus x squared. So that means y is equal to square root 1 minus x squared. So we're going to substitute that in for y. So that is 1 minus x squared. So now we get inverse sine of x is theta. So we need to solve for 1 over cosine of theta. Well, cosine of theta is just adjacent divided by hypotenuse. So that's just square root 1 minus x squared divided by 1. That's just square root 1 minus x squared. So that means our inverse sine is just 1 divided by 1 minus the square root of 1 minus x squared. And that is our formula for our inverse sine, which I believe is pretty interesting. Okay, so I'm going to delete this so we can get some room later on to deal with cosine. But I kind of want to save this formula, so I'm just going to move this here and move this to the side. Okay, now let's do cosine. So cosine of x. To do cosine of x, we do the same procedure. So cosine of inverse cosine of x is equal to x. Now we took the derivative of cosine, that's negative sine. Keep whatever's inside the same. Since it's a function inside of a function, then we had to use the chain rule. So the derivative of cosine, of inverse cosine I mean, which is what we're looking for. And that's equal to the derivative of x, which is 1. So that means the inverse cosine, the derivative of the inverse cosine is 1 divided by negative sine of cosine 1 of x. And we're going to do the same thing again, drawing theta. So this x value, since it's cosine, is going to be adjacent over hypotenuse. That means this one is the x. So x divided by 1 will give us x, which is what it's here. So now, instead, so if this is x, that means this value is going to be 1 minus x squared. Okay, so that means sine, this simplifies to 1 divided by negative sine of theta. That's what we did before. And then sine of theta is going to be square root 1 minus x squared divided by 1, which is just square root 1 minus x squared, and then we have a negative. So that's negative 1, so I just moved the negative on top, and then square root 1 minus x squared. And that gives us our formula for inverse cosine. And I want to compare these two values. Okay, let's compare these two formulas. So let's look at this. Looking at sine, the derivative of our inverse sine is positive, and square root 1 minus x squared on the bottom. And our derivative of our inverse cosine is negative, and square root 1 minus x squared on the bottom. So that basically means that these two are basically almost the same, except that one is negative and the other one's positive. And I think that's a pretty interesting correlation. So let's try an example that uses this fact. So let's say f of x is equal to 3 inverse sine of x plus 2 inverse cosine of x. And we want to find the derivative at x is equal to square root 3 over 2. So taking the derivative of each of them, so 3 is a scalar, so we leave it alone. Derivative of inverse sine, we already got it. That's 1 over square root 1 minus x squared. Then 2 times inverse cosine is negative 1 square root 1 minus x squared. Well, this is positive and negative each other, so we subtract them. So 3 minus 2 is 1. So that's just 1 over square root 1 minus x squared. Now we just need to plug in our x in there. So that means square root 3 over 2 squared is 3 over 4. 1 minus 3 over 4 is 1/4. And then we take the square root of 3 over 4. 1 over 4 is 1/2. So this is just 1 over 1/2, which is 2. So the derivative of our function of f at x equals square root 3 over 2 is 2, which is also the slope at that point. Well, that basically covers what I wanted to cover for this video. In the next video, I'll cover the derivatives for inverse tangent and inverse cotangent. Well, thanks for watching.